get started on 4.2, are there questions on the homework? Now, depending on how y'all feel about these here, there's a good chance we're actually going to blow through these note sheets pretty quickly. Okay? The first few problems we're going to go over adding two polynomial expressions. Hopefully this will be a refresher. We've done this before. Now, I don't know if y'all have added two polynomial expressions vertically, but all we do to add them vertically is we take the first expression and we're going to write it down. So 3x squared plus 2x minus x minus 7. If there's a term missing, we can either leave it blank and just leave a spot for it. So if there was no x term, we would just move over and put the negative 7. So if there's a spot for it in the other place, do that there. Or if there is no x term, we can just fill it in as 0x. Or if there is a term missing, we'd fill it in as 0 times that term. And the main reason, or main way we would know if a term is missing, so we look at our variable at the biggest exponent, so x cubed is the variable at the biggest exponent, so we would need an x cubed term, x squared, x constant term. We need every term following it. Here we have them all. Now we're going to put our second expression underneath it. So our first one is x cubed. We would put it under its like term with 3x cubed. Our negative 10x would go underneath our x squared. Then we have plus 8. Well, that's our constant term. So it would go under the minus 7. We wouldn't put it under the negative 8 and negative x, because it does not have an x. That second expression does not have an x term. So in the second expression, we can just leave it blank. We don't have an x term under our negative x. Or the other option is just to write plus 0x. Questions on how we set this up? Now, we're going to do what it told us to. We're going to add. I like putting a plus between each of our like terms, just a reminder to myself that we are adding these two together. So 3x cubed plus x cubed, 3x cubed plus x cubed, 3 plus 1 is 4x cubed. 2x squared plus negative 10x squared, 2 minus 10 is negative 8x squared. Because with addition subtraction, we're just adding or subtracting the coefficients. We're not doing anything to our variables. Our next one is negative x plus 0x. Negative x plus 0x. Negative 1 plus 0. Just negative 1 or negative x. We're not adding anything to it. We're not taking anything away from it. It just stays negative x. And lastly, negative 7 plus 8 would be plus 1. Questions on this here? We feel good with this here. Are you ready for the next one? Now, adding two polynomial expressions horizontally. This is how we're going to see it. This is how it's going to be written. This is what I think we're used to doing. We're used to adding or subtracting horizontally. Vertically, we might have seen it before. You might have done it before, but it might not be as familiar as horizontal. Questions on this so far? Now, the first thing we want to do is simplify our parentheses. Now, because there's nothing in front of this first set of parentheses, realistically, we can just drop the parentheses, leaving us with 9y cubed plus 3y squared minus 2y plus 1. The number and the signs or values of each of our monomial expressions isn't going to change. It's the exact same. Now, the second set of parentheses, we're really going to distribute that positive 1 through. That's actually what we did with the first set. But nothing's going to change. We still have negative 5y squared. We still have positive 1y, and we still have negative 4. Because it's a plus, there's no number in front of it. We can really drop that second set of parentheses as well. Questions on this here? Now, at this point here, we can start combining like terms. Now, one thing we could do is go through and rewrite it so that our like terms are next to each other. 9y cubed doesn't have any like terms, so it's just 9y cubed. Our next set would be our y squareds. So our 3y squared and negative 5y squared. Positive 3y squared and negative 5y squared. Our y terms are negative 2y and positive 1y. And lastly, our constant terms, positive 1 and negative 4, giving us this here. Now at this point here, we can just combine like terms. Well, 9y squared doesn't have any like terms, so it's just going to stay 9y squared, or 9y cubed. Sorry, not squared. Our squared terms, 3y squared minus 5y squared. 3 minus 5 is going to be negative 2y squared. Our y terms, negative 2y plus y. Negative 2 plus 1 is going to be negative y. And lastly, 1 minus 4 is negative 3. So we have 9y cubed minus 2y squared minus y minus 3. Questions on this here? We feel good with this here. We kind of remember doing this before. Or doing something like this, just our combining like terms, adding, subtracting. We're ready for the next one. We'll do one more of these here. I know it says vertical. Do we like doing it vertically or horizontally more? Vertical. We'll do one more vertical. So vertical, I would write the first one out. If there's any spaces, we can fill them in as 0x. Here we have x cubed, x squared, x in our constant term, so we do have all of our terms. We're not missing any. Then we can put the second one underneath it. We'll put x cubed, our first term, under the x cubed term. Our next term is our 7x squared. So we'll put our plus 7x squared under the x squared. Again, it didn't give us an x term, so we can put it in as 0x. And then we'll put our minus 2 under the plus 4 so that we have all of our like terms lined up. And then it told us to add these two together. So 2x cubed plus x cubed, 2x cubed plus 1x cubed is going to be 3x cubed. X squared plus 7x squared, 1 plus 7 is going to be plus 8x squared. Negative 3x plus 0x, negative 3 plus 0 is x, negative 3x, yes. And lastly, 4 plus negative 2, 4 minus 2 is plus 2. 3x cubed plus 8x squared minus 3x plus 2. Questions on this here? Do we feel comfortable with adding two polynomial expressions together? Yes. Do we need to see another example of addition? No? Okay. If we feel good with this here, we'll move on to subtraction. And I will say this, and this is true with addition or subtraction. If you want to add them vertically, add them vertically. If you feel more comfortable adding them horizontally or subtracting horizontally, do that. I am not going to specify a method for addition or subtraction. Do it whichever way you feel more comfortable or you feel you better understand. Now with subtraction, we do need to be a little careful because whichever one comes first, if we're going to subtract vertically, we put on top. Whichever one is listed first, whichever one has the minus, is in front of the minus sign, the parentheses that's in front of the minus sign is going to go on top. The expression that comes after the minus sign would go on bottom. And if there is a term missing, and especially for this here, it's going to be helpful to put it in as plus 0 times that variable. So if the x squared term is missing, either on the first or second, we can put it in as plus 0x squared. Now we know we're missing a term because it's going to be in decreasing power. Since x cubed was the variable at the biggest exponent, we would need an x cubed term, an x squared, an x, and a constant term. And since we're subtracting, I would put a subtraction sign between each of our like terms. Just as a reminder to myself that we are subtracting all the way through. Especially when these get bigger, I've done it before. I subtract the first two and then I start adding later on, or I don't distribute that negative all the way through. Questions on this so far? So let's go on and subtract. So 2x cubed minus 8x cubed, 2 minus 8 is going to be negative 6x cubed. Our next one is 6x squared minus negative 3x squared. Well, the negative and negative make a plus. 6x squared plus 3x squared is going to be plus 9x squared. Our next one is negative x minus negative 2x. Well, the negative and negative make a positive. Negative x plus 2x. Negative 1 plus 2 is going to be plus 1. Positive 1 or plus x. And lastly, 1 minus 9 is negative 8. Negative 6x cubed plus 9x squared plus x minus 8 is our final answer. Questions on this here? Are you ready for the next one? So we're going to subtract this horizontally. So our first set of parentheses, we need to resolve those first. Since there's not a sign or a number in front of the parentheses, we can just drop them and everything inside those parentheses is going to stay the same. So we'll still have 3z squared plus z minus 4. However, the second set of parentheses, we will need to distribute that negative through both terms. So our positive 2z squared is going to become negative 2z squared. Our positive 3z is going to become negative 3z. And since we don't have a constant term, a term without a variable in the second expression, we don't have to worry about it. Questions on how we got to this point here? You feel good with this so far? Now we need to combine like terms. Now when we combine like terms like we did before, we can write them next to each other. Or we can just look at this here. 3z squared and negative 2z squared are like terms, yes? So 3z minus 2z squared. 3 minus 2 is going to be positive 1, or z just z squared, yes? Our next set of like terms is our z and negative 3z. Z minus 3z, 1 minus 3 is going to be negative 2z. And lastly, we have our constant term in negative 4. Well, there are no other like terms with negative 4. So it's just minus 4. So we can jump straight to there and just start combining our like terms. If it is helpful to write our like terms next to each other and then combine them, write them next to each other and combine them. If you don't need to do that, that's fine. Just start combining our like terms. But if you do find it helpful, or it helps you to be able to write them next to each other before combining, do that. Questions on this here? Questions on subtraction? Do we need to see another example of subtraction? No? Okay. If we feel good with addition and subtraction, we're just going to move on to multiplication. Because again, I put a good number of example problems in here if we need them. If we don't, we're just going to keep moving. Multiplying. The nice thing with multiplication, order does not matter when multiplying polynomial expressions. As we learned before Thanksgiving, multiplying matrices order does matter, because two matrices being multiplied together, order makes a difference. And we're going to multiply, we're going to distribute through. So the first thing we're going to do is multiply through by negative x squared. So we're going to do negative x squared times x. Well, for one thing, it is going to be negative. X squared times x is going to be x cubed. Because when we multiply like bases, we add the exponent, so 2 plus 1 gives us 3. Negative x squared times negative 3, well, the negative times a negative makes a plus. And x squared times 3 is going to be 3x squared. Questions on this here? So we've multiplied through or distributed all of our possible outcomes with negative x squared. So now we're going to repeat the process with 2x. 2x times x is going to be plus 2x squared. 2x times negative 3, 2 times negative 3 would be negative 6. And we do still have our x. And lastly, we need to distribute the 4. 4 times x, positive 4 times positive x is positive 4x. And positive 4 times negative 3 is negative 12. Yep. Questions on this here? So we have finished multiplying out. Now we need to combine like terms, yes? So I always start with the variable with the biggest exponent. So that's our x cubed. Does it have any like terms? Nope, so it's just going to be negative x cubed because there's nothing to combine it with. 3x squared and 2x squared, well, luckily our x squared terms are right next to each other. 3x squared plus 2x squared, 3 plus 2 is 5x squared, positive 5x squared. So we have plus 5x squared. Then we go to our next set of like terms, our x's. Negative 6x plus 2x, negative 6 plus 4. Sorry, not negative 6 plus 2x. Negative 6 plus 4x. Negative 6 plus 4 is negative 2x. Yeah. I went on and said the answer instead of what we actually had to add. And lastly, negative 12. Are there any like terms with it? Nope. So we just say minus 12. So that tells us this product is negative x cubed plus 5x squared minus 2x minus 12. Multiplying these starting to come back a little bit. I mean, it's like FOIL, first, outer, inner, last. But we have to do just a few more. We ready for the next set? This time they kind of have it flipped. We're multiplying y plus 5. And 3y squared minus 2y plus 2. So we multiply this out. The first thing we're going to have to do is distribute the y all the way through. So we're going to have y times 3y squared. Well, we'll still have 3. And y times y squared is y cubed. Y times negative 2y would be negative 2y squared. And y times positive 2 is going to be positive 2y. Questions on this so far? Now the next thing we're going to multiply through is the positive 5. 5 times 3y is going to be plus 15y squared because our 5 times the 3 is 15. We still have our y squared. 5 times negative 2y, 5 times our negative 2 is going to be negative 10y. And lastly, 5 times 2 is plus 10. Which one? 2y squared? Here? This one here? So 15, 5 times our 3y squared. So we multiply the 5 and 3. But the y is already squared from the 3y squared. So we do 5 times 3y squared to get here. So our 5 times 3 gives us the 15. And then y squared just comes down with it. Because really what we're saying for this here, I'm going to get a different color. 5 times 3y squared is we have 5 times 3 times y squared. So 5 times 3 is 15, and then y squared.
What about the 2?
So here, this one, we're doing y times negative 2y. So we have negative 2 times our y times our y. Does that make sense? Yeah, because here, y times 3y squared, we have the 3 times y squared. Now, I am rewriting it a little bit. Plus, in the middle, it's going to be negative 2 times 5 times y plus 2 times 5. And we put kind of the like terms, the coefficients in front and multiply, and then our variables will multiply. Does that kind of make a little more sense? Yeah, we kind of skipped through that because I feel like by this point we are comfortable. If not, that's fine. But does that breakdown kind of make sense from there to there? Yeah. If any of this doesn't make sense, ask. Any other questions on this here before we move on? Now at this point here, we're going to combine like terms. Well, 3y squared, 3y cubed is our only y cubed term. So it's going to be y cubed. At this point here, our 2y squared and 15y squared, negative 2 plus 15, is going to be plus 13y squared. Then we move on to our y terms, our 2y minus 10y. 2 minus 10 is going to be negative 8y. And lastly, our constant term doesn't have any like terms, so it's just going to be plus 10. Questions on this so far? Questions on multiplication? We're going to skip, we'll do one more. So for this here, we're going to multiply 3 together. And really multiplying 3 polynomial expressions together isn't any different than multiplying 2. It's just that we're going to multiply 2 of them together, simplify, and then multiply the results. And the order in which we multiply them doesn't matter. We can do x minus 1 and x minus 4 first. We can do the x plus 4 and x plus 5 first, or I wouldn't suggest it, x minus 1 and x plus 5. Doesn't matter which one we do first, we just got to multiply 2 of them together first. What I'm going to multiply first is the x minus 1 and x plus 4. So we're going to distribute the x first. X times x is x squared. X times 4 is going to be plus 4x. Then we're going to do the same thing with negative 1. Negative 1 times x is negative x. And negative 1 times 4 is negative 4. Telling us that we have x squared plus 4x minus x minus 4. Now, if it wasn't for the fact we're still multiplying it by the x plus 5, we wouldn't put parentheses. But since we do have that one more multiplication, we do need to include the parentheses. Now at this point here, we can simplify our like terms. Now our 4x and negative x, 4x minus x is going to give us 3x. It's going to give us 2 less terms than if we leave it alone, because it's going to be nicer to simplify where we can, when we can. Questions on this so far? And then lastly, we're going to multiply one more time. So we're going to distribute the x squared first. X squared times x is going to be x cubed. X squared times 5 is going to be plus 5x squared. Three x times x is going to be plus 3x squared, and 3x times 5 is going to be plus 15x. And then lastly, we're going to distribute the negative 4. Negative 4 times x is going to be negative 4x. And lastly, negative 4 times positive 5 is negative 20. Questions on how we got to this point here? Last thing we have to do is what? We're going to simplify, combine like terms. X cubed doesn't have any like terms. Our 5x squared and 3x squared, 5 plus 3 is going to be 8x squared. 15x minus 4x plus 11x And negative 20, our constant term, doesn't have any like terms, so we're just left with negative 20. So x cubed plus 8x squared plus 11x minus 20. Questions on this here? Do you feel comfortable with multiplying? All right. Now, I did include this here in your notes, the special product patterns. Really, this is if we notice that we have a plus b times a minus b, or one of these here, it gives us a way to multiply quicker and faster. Are they necessary? Are they required? No. We can still multiply them together and get to the same result. It's just if we notice the pattern, it will work a little quicker. But I'm not too concerned with that there. And that's it for 4.2. 4 through 14 even, 18, 19, 21, 25, 27, and 30. I think it is the 19 is the error detection. One of them is the error detection. I can't remember which. 25. 25 is the error detection problem. So all you're doing is looking at what they did and seeing what they did wrong, telling what they did wrong, and then fixing it.